Hello everyone, I am Shrestha Reddy Parvat Reddy and I am from Group 7. Today we'll be presenting on the topic Similarity Measures using Vectors, and I will be describing what similarity measures are and what types of similarity measures there are and what are the values that we use for similarity measures. So beginning with the introduction, firstly, what does similarity measure mean? Similarity measure determines how closely two given data samples are related or connected. So how is this useful? Similarity measure is useful in finding patterns within the data. Like how is the data related? What is the data that we can extract using patterns? So when we find a pattern within a data, we understand how the user is, like what are the user's preferences, etc. And this is very useful in today's big data. So if the distance between two items or two given data samples is small, then the objects will have a higher level of similarity between them. And if the distance between two given data samples or objects is high, that is, they have a huge distance between them, then they have a lower level of similarity. So that is what we see here. There is two items that have a smaller distance, then the objects will have a higher level of similarity. And for a larger distance, we have a lower level of similarity. So the similarity measure is usually described using a numerical value, and the numerical values are between 0 and 1. So 0 indicates a lower similarity. That is, 0 indicates the similarity between like objects far away from each other, as we previously discussed, and 1 indicates a higher similarity. That is, usually 1 is used for objects that are very close nearby to each other. So this is the numerical values that we use to describe similarity measures. And going further ahead, now we're going to see the different types of similarity measures. So there are namely 4 different types of similarity measures, and each one is used for different types of data. Each one has its own pros and cons. So the 4 different types of similarity measures are cosine, correlation, Euclidean, and Jacquard. Now, I'm going to describe about each of these types briefly, just to say like how they work and how they work efficiently. So let's start with the first type of similarity measure, that is the cosine. So the cosine determines the similarity between two documents irrespective of the sizes. That is, when we give two data samples to cosine, it determines the similarity between them even though there are very limited amounts of data or very huge data. That is, cosine works in the same way with small data as well as large amount of data. So that is one pro of cosine. Next, we have the correlation similarity measure. The correlation similarity measure is something that's extracted from the cosine precisely. So it's basically a cosine similarity of x and y within the range of -1 and 1. So the correlation is essentially derived using the cosine similarity, but then it sticks to the range of -1 and 1. So next is the Euclidean. So the Euclidean is generally used in cluster analysis algorithm. So most of the cluster analysis algorithm use the similarity measure of Euclidean, and the distance between two given data points can be stated using the Euclidean similarity measure. And finally, the last similarity measure is Jacquard. Jacquard can be simply defined as the size of the intersection divided by the size of the union sample sets. So when we divide the size of intersection by union sample sets, we get the Jacquard measure. And Jacquard measure is usually used for similarity between finite sample sets. So these are the four types of similarity measures and the brief description of how they are. Now we'll look into it further.